Hello everyone, my name is Xiang. I'm from Good Karma. My another two members are Shun and Azul bin Danin. So today I'm here to present about the good project about the constant strain triangle analysis. Next, I will give some introduction about this good project. So in this good project, we need to use the finite element analysis to determine the displacement stress and strains on the thin plate, and then the analysis can be done by using the finite element analysis software, and since with a list of 12 triangular elements, then the obtained results to the quantum motor can be used for the entire surface of the plate. Okay. Besides that, we also can do the comparison with the analysis result that obtained through the octave. Next, so our objective of this good project is to apply the knowledge learned to the CST element and then do the finite element analysis on the thin plate. Second, to solve the FEM model by using simplified element in appropriate boundary condition by using scenes and manually. Lastly, the objective of this project is to apply the team working skills in order to solve the problem faced. Okay, next. So now I will explain the paradigm inside this project. Okay, in this RD, this data were given. For example, the Young modulus E is equal to 207 G Pascal, and then for the Poisson ratios, the V is equal to 0.3, and then the ratio of R per D is given in 0.25, and then a ratio of W per D is given in 1.2. So based on the data given, we have some assumption on the value. For example, the R is equal to 5 cm and the W is equal to 24 cm, and then for the D is equal to 20 cm, and lastly the L is equal to 20 cm also. And then, okay, as you can see, we have choose the top left photo body for the whole thin plate for the analysis. So the result calculated actually is same for the entire body of the thin plate. And then we have labeled some points, for example, point A, point B, and point C on the quantum motor so that easier for our calculation. Next. So in the problem modeling, we have choose the plane stress condition. This is because the geometry of the quantum motor is quite thick in compared to the entire area of the model. Okay, so while we setting the appropriate boundary condition, okay, we fix the point on the bottom right is the fixed support part. So this is a point D, is a fixed support part. Okay, and then at the left hand side, at the bottom left hand side, we set the axial tension force, which is a 100 Newton, and this axial tension log is point C, and we set it here. Okay, so lastly, the roller support is needed to set at this bottom part and the right hand side part of this quantum model. Okay, this is our bottom modeling while we setting the appropriate boundary condition. Next, so this 15 element as since analysis result. Okay, so this one is the result for the x directional deformation, and then the minimum x directional deformation is at here, and then the maximum x directional deformation is at here. Okay, so for the results of the x directional deformation for point A, point B, and point C is at here. Okay, point A, point B, and point C. The result will show in the table at the next slide. Okay, for the y directional deformation, this is the result. Okay, is the maximum y directional deformation and the minimum y directional deformation. And then for the results of the y directional deformation at point A, point B, and point C is here. Okay, point A, point B, and point C. Okay, the results will show in the table at the next slide. Okay, so for the This is the result for the normal stress. Okay, this is the minimum normal stress, and this is the maximum normal stress. Okay, for the results for normal stress in point A, point B, and point C is shown at here. Okay, so the result will show in the table at the next slide. Okay, so for the result of the normal elastic strain, okay, so this is the minimum normal elastic strain, and this is the maximum. Okay, if you want to find the magnitude, again, you can read it here, okay. So for the results of normal elastic strain for point A, point B, and point C, okay, will show in the table at the next slide. Okay, next. So the result of the x directional displacement and the y directional displacement and the stress in x directional and in y directional and the strain in x directional and y directional is shown here. Okay, so this is the results for the point ABC in the displacement, stress, and the strain. So next, I will pass my slide to my next teammate. Okay, thank you.